Here's problem 35:15. A diver shines light up to the surface of a flat, glass-bottomed boat at an angle of 30 degrees relative to the normal. If the index of refraction of water and glass are 1.33 and 1.5 respectively, at what angle in degrees does the light leave the glass relative to the normal? Alright, so we're looking up. The source of this light is coming from inside the water, where our index of refraction is 1.33, and so there's going to be some light here coming from a flashlight, and it's going from a index of 1.33 to the glass, which is 1.5, so it's going to a higher index of refraction, so it's going to bend towards the normal, come in this way, and then as it encounters the interface to the air, which is inside the boat, it's going to refract away from the normal, like that. So we're dealing with an angle of incidence, let's call it theta 1, and then we have an angle of refraction into the glass, let's call it theta 2, and then at theta 2 will actually be our angle of incidence into the air, because we have two parallel lines with one line intersecting, and so our internal angles should be equal. So the angle of refraction into the glass will equal the angle of reflection out of the glass, or angle of incidence out of the glass. And then we have an angle theta 3, which is our angle of refraction in the air. As we look at these interfaces with the light originating in the water and going up, eventually reaching the observer's eye, we can apply Snell's law to this problem. So we have n1 sine theta 1 should equal n2 sine theta 2. But for the second interface, it would be true that n2 sine theta 2 is equal to n3 sine theta 3, and theta 2 and theta 2 is the same, so our middle term is the same for both of these. So we can actually cut that out and think of this as n1 sine theta 1 is actually equal to n3 sine theta 3. We want to find theta 3. We want to find the angle the light leaves the glass relative to the normal. So theta 3 is going to be equal to the inverse sine of n1 divided by n3 sine theta 1. So it'll be inverse sine of 1.33 over 1 sine, and it was 30 degrees incident. So that is equal to the inverse sine of 0.665, which would be equal to 41.7 degrees. So the angle that the ray leaves the glass with into the air of the boat is 41.7 degrees.